we are at the end of Chapter 2. Today we're going to look at proving angle relationships. And some of these things will be things that we've already done, but again, now we're just giving names to them. So the angle addition postulate says that if you have a point, so let's say if point B is on the interior of angle ABC, then, and I actually like to just kind of leave this blank for right now and go ahead and draw the picture. So if I have a point D on the interior of angle ABC, well, do you see how that forms these two separate angles here? So what I can do is I can say that these two smaller angles add up to equal the whole thing. So I'll go ahead and just put a little angle 1 and angle 2 in there so we could notice that, or you could have it written out that the measure of angle ABD, or that's angle 1, plus the measure of angle DBC, which is angle 2, equals the measure of angle ABC. And we've done work like this before. These two small angles add up to equal the whole thing. Now we just are putting the name to that. That's called the angle addition postulate. For the next one, the supplementary theorem says that if you have two angles that are a linear pair, then they're supplementary. And again, we've done work like this before. We're just giving it a name now. So if two angles form a linear pair, then they are supplementary. Okay, for the next part, we have the complementary theorem. Again, something we've looked at, but now we're just giving a name to it. This says if two angles are adjacent, so they're right next to each other, and they form a right angle, then they are complementary. And what you can do for both of these is when you have these in your picture, you can say that they're complementary or you can say that they're supplementary, and then you can use the definition of those things to say that they either add up to be 180 degrees or they add up to be 90 degrees, and then you can go ahead and do your proof from there. So in this case, I'll just do one of these and kind of write it out a little more. But if this were given to me that I have this picture, I could say that angle 1 and angle 2 are complementary. And that would be my statement if you were thinking about this being in like that two-column proof chart. And the reason I know this is because of the complementary theorem. And I'll just abbreviate complementary theorem, THM. And then what I can say is because of the word what complementary means, that means that these angles add up to equal 90 degrees. And this would be the definition of the word complementary. So I know it seems a little redundant. That's just kind of how it is. You have to pretend like you're talking to somebody that maybe doesn't know what that word means. So you can say, oh, when they look like this, that means that they're complementary. And they're like, wait, what does complementary mean? And then you have to say that, whoa, that means that they add up to equal 90 degrees. Okay, and then the last one here is the vertical angles theorem. For the vertical angles theorem, when you have vertical angles in the picture, the vertical angles theorem just says that they are congruent. So I'm going to say that if angle 1 and 2 are vertical angles, then they are congruent. So if angle 1 and 2 are vertical angles, then angle 1 is congruent to angle 2. And what each of these would allow you to do is come up with some sort of equation, because if they're congruent, that means they're equal, or if they're complementary, that means that they add up to 90, or if they're supplementary, that would let you know that those angles add up to be 180. So we're going to come up with an equation, then we'll be substituting things in, and then we'll be solving for whatever they're asking us to solve for. So that's the direction we're going with all this. I'm going to go through these next three really quick, just so you can see an example of the reflexive property. This is when something's equal or congruent to itself. So this holds true with angles too. For example, angle 1 is congruent to angle 1. The symmetric property might say if, let's say, the measure of angle A equals the measure of angle B, then the measure of angle B is equal to the measure of angle A. And this would work for equal or congruent, doesn't matter. Just kind of giving you a quick example of these. And then the last one, the transitive property, this is when you have one thing congruent or equal to a second thing. So angle 1 is congruent to angle 2, and you know angle 2 is congruent to angle 3. Well, what the transitive property says that you can do is you can say that angle 1 is congruent to angle 2. These next couple things, the congruent supplements theorem and the congruent complements theorem, these are on page 153 in your book if you need to kind of see these a little bigger. I'm not going to ask that you write it all out, but you do need to kind of understand what it's saying. So the congruent supplements theorem says you have two angles that are congruent that are supplementary to the same angle. So here in this picture, angle 1 is supplementary with angle 2. Also, angle 3 is supplementary with angle 2. So I have these two angles that are supplementary to the same angle. Well, that would let you know that angle 1 is congruent to angle 2. So it's called the congruent supplements theorem. This example here might be something that you want to write down. But when things are supplementary to the same angle, they are congruent to each other. And the congruent complements theorem basically says the exact same thing, except now we're going to have two angles that are complementary to the same angle. So here in this picture, angle 4 and angle 6 are both complementary with angle 5. So what that would mean about 4 and 6 is they are congruent to each other. So when they are complementary to the same angle, then they are congruent to each other. And these are theorems. These things can be proven. We are not going to go through proofs of these, at least not at this time. But theorems you can prove using other reasons. Okay, so here is what most of these questions are going to look like, or an example of what they could look like. We need to make sure we are paying attention to what is given and then going off of information from that. So for these, again, we're going to be making a two-column proof. We are going to start by writing out what's given. So here it says that DB, so ray DB, bisects angle ADC. And that's all that I have given, so I'm just going to write that out. But I'm going to go over here to my picture and look and see what that means about this information on the picture. So DB bisects angle ADC. I think to myself, what does that mean? What does that mean if that bisects this angle? And what it means to bisect is it means that it cuts the angle into two congruent angles. So in this case, these two congruent angles would be angle 1 and angle 2. So what I can say is I can say that angle 1 is congruent to angle 2. And the reason I can say this is because that's what the word bisect means. So that is a definition, if it's ever just what that word means, definition of an angle bisector. Or if you just want to write down definition of bisect, I'll accept that. I'm just going to be a little more specific here. Okay, so looking at this, that's really all I have to go off of, unless I look at the picture, because I want to somehow link together that angle 2 and 3 are congruent to each other. So if I look at this picture, do you notice I have a couple of straight lines here? And I have these two angles, 1 and 3. Those angles there are vertical angles. So what I can do next is I can say that angle 1 is congruent to angle 3. And my reason here is these are vertical angles. So I'm going to write down that this is the vertical angles theorem. Well, and then lastly what I have is I want to somehow say why 2 is congruent to 3. I know that 2 is congruent to 1, and 1 is congruent to 3. Wouldn't that allow me to say that angle 2 is congruent to angle 3? It would. This right here really could be one of two reasons, kind of depending on how you look at it. This is probably a better example of the transitive property, where you have one thing congruent to a second thing, that same second thing is congruent to a third thing. So I would write transitive property here. Some people have made the case for this is substitution, and really it's like substitution also, where you're just taking angle 2 and putting it in place of angle 1 because you knew that they were congruent or equal up here. Either way, I wouldn't mark it wrong if you wrote that on the test. Okay, and then sometimes for these, you're going to have maybe some other given information. So let me say that maybe they tell you that angle 3 is 6x plus 2, and angle 1 is 8x minus 14. Well, if this were the case and you were asked to write a proof for this, what you could do is you could say that angle 1 is congruent to angle 3, because of the vertical angles theorem. You could say that the measure of angle 1 equals the measure of angle 3. I don't know why I keep saying 2. Because the definition of congruent angles. And then what you could do is you could use substitution to say that 8x minus 14 is going to equal 6x plus 2 with substitution. And then this looks just identical to one of those algebraic proofs, where you're going to use the subtraction property to subtract 6x from each side. You're going to use the addition property to add 14 to each side. And then you're going to use the division property to divide 2 from each side. So x would equal 8. So then the last bit of this section just gives us 5 different right triangle proofs, or right triangle theorems. For all of these, I don't expect you to have these memorized, which one's 2,9 and which one's 2,10, etc. But you do need to answer questions about them, so I'll just run through them really quick. So 2.9 says perpendicular lines intersect to form 4 right angles. So by definition, it would say 1 right angle. But if this is a right angle, wouldn't all of those be right angles? Because we have vertical angles, we have angles that are supplementary. So if one's a right angle, technically all 4 of them are right angles. The next one here says that all right angles are congruent. So a right angle is 90 degrees. So if you have one angle that's 90 and another angle that's 90, that means they're congruent to each other. Perpendicular lines form congruent adjacent angles. So these 2 angles here that are adjacent would be congruent because they're both 90. If 2 angles are congruent and supplementary, then the angle is a right angle. So if you have 2 angles that are supplementary, meaning they add up to be 180, and they're the same, that means both of them need to be right angles or both of them need to be 90. And then the last one says if 2 congruent angles form a linear pair, then they're right angles. That's just kind of another way of saying the way I have it drawn in this picture. So hopefully these things all just kind of make sense. They're all quick. And don't forget this symbol here. Some of you guys forgot this on the last test. This symbol here means that they are perpendicular. Okay, now it's just time to get ready for Chapter 2 test.